Hello everyone, welcome to the continuation of the HCI IoT courses. Today we will learn about NB-IoT communications technologies and solutions. In the previous course, I introduced several common IoT communications technologies. In this course, I will introduce the key technologies and features of NB-IoT, as well as some NB-IoT solutions. As we mentioned before, IoT scenarios are different from the traditional internet used by mobile phones and computers. What are the characteristics of IoT in wireless communication scenarios? First, IoT devices at the sensing layer send and receive data packets that are small and transmitted infrequently. Some of them may send less than 10 bits of data in an entire day. Second, these devices need to conserve power even during communications in order to prolong their service life. So, small packets are occasionally transmitted through passive devices. The communications network needs to run on very little power and cover a wide area, which is why we call this an LPWA or low power wide area scenario. Upon completion of this course, you will have a better understanding of the evolution of NB-IoT standards, the development of the NB-IoT industry, key technology of NB-IoT and NB-IoT solutions. First, let's see why NB-IoT is so important and how NB-IoT is developing. As we mentioned in the previous course, NB-IoT was proposed by Huawei and Vodafone, and vendors such as Qualcomm and Ericsson joined later. NB-IoT evolved out of NB-IoT M2M and was officially named NB-IoT in 2015. In 2016, the NB-IoT standards were officially frozen, but it did not stop evolving. Many new features were introduced in Release 14 in 2017. NB-IoT Release 14 has a higher transmission rate and supports set positioning and multicast. At the latest conference on July 9, 2020, NB-IoT was incorporated into the overall 5G plan. This event indicates that IoT devices that access the network through NB-IoT can connect to the 5G core network and use 5G services such as edge computing and network slicing. During the selection of LPWA technologies, most operators choose to deploy NB-IoT networks first and then add an eMTC network later. This is because they would rather deploy a network that provides entirely new functions. Before the emergence of NB-IoT, there were no LPWA networks, and there were no networks specially designed for IoT devices. The operator networks we are using today are designed for human beings to facilitate communications between human beings. These networks provide voice communications and are always being optimized for higher and higher transmission rates. In contrast, NB-IoT networks provide very slow transmission rates. User experience would be poor if we tried to use NB-IoT networks for our mobile phones. However, NB-IoT networks are suitable for devices, since these devices are typically widely separated, need to run on limited power, and do not need to transmit much data. As for the eMTC network, as we mentioned in the previous course, it has a higher rate than NB-IoT and supports voice communications. It is similar to a 2G network that way. We can use eMTC to replace an old 2G network, but it is not as urgent as NB-IoT. This is why most operators choose to deploy NB-IoT first. In addition to technology selection, there is another problem that operators must consider: spectrum selection. The network frequency band must be low enough to meet requirements for both coverage and penetration. IoT devices at the sensing layer, such as gas meters or water meters, are often placed in the cabinets in kitchens. They need frequencies with strong penetration. A low frequency band means strong penetration. Most operators deploy networks on the sub-GHz frequency band, on frequency ranging from 700 MHz to 900 MHz. A few operators, like China Unicom, deploy their networks on the 1800 MHz band. As we mentioned in the last course, NB-IoT networks are mainly deployed on the sub-GHz frequency band, but not all of them. NB-IoT networks are based on 4G LTE networks. Operators can upgrade some 4G base stations to function as NB-IoT base stations. The case is different for China Unicom, because China Unicom's 4G base stations were already upgraded from 3G base station. They can directly upgrade their 3G 1800 MHz base stations to support NB-IoT, saving a lot of money. That is why China Unicom chose to deploy NB-IoT networks on the 1800 MHz frequency band. In addition to network technologies, base stations, and frequency bands, chips that support connections between devices and base stations are required. Huawei launched Botica 120 chips as early as release 13. This chip supports the sub-GHz frequency band, but not mobility features introduced since release 14. Huawei launched Botica 150 chips to support the new release 14 features. Now, let's look at some NB-IoT applications. NB-IoT involves many fields like water meters, gas meters, street lamps, and smart parking. I will introduce some NB-IoT solutions at the end of this course.